So this is the code I should describe. Let's start with the variable m, which seems to be not used anywhere in the code. It seems to be declared but not utilized. The next is a method for printing. It goes through each row and column of the matrix and prints the elements. Then the static method perform operation. This function reduces matrix to reduced row echelon form. So it takes a 2D matrix A of size n times n plus 1 as input and returns a flag which indicates whether the RREF is successfully obtained or not. So all the integers and the flag are set to 0. The floating point pro is also set to 0. The for loop performs elementary row operations. The outer for loop iterates over the rows of the matrix. The first if statement checks the diagonal element of present row, and if it is equal to 0, then it swaps the row with another row to avoid division by 0. The while loop runs when the diagonal element is 0, and keeps incrementing C until it finds a row where the diagonal element is not 0. So basically it searches for the next non-zero diagonal element below the current row. The next if statement does the following. So if the while loop completes and C reaches the value such that I plus C is equal to n, it means that all the elements below the current row in the same column are also 0. In this case, the matrix is not invertible and the variable flag is set to 1 to indicate this condition, and the outer loop is broken using a break. And the for loop is for swapping the rows. So if the first if element condition is true and C is greater than 0, then the code reaches this part. It swaps the current row with the row found by adding C, and this way the current row now has a non-zero diagonal element. The second for loop runs for each row in the matrix A, excluding the current row indexed by I. It converts the matrix to reduced row echelon form. It uses the float P, which is the ratio between the current row element and the diagonal element of the current row. Then it subtracts this ratio times elements of the current row from the elements of each row. This way it zeroes out all elements below and above the diagonal in the column indexed by I. So after the outer loop completes, the matrix A will be in reduced row echelon form, and the function returns the value of the flag variable, which indicates if the matrix is invertible or not. The next method here is for printing results. It takes in 3 parameters. It prints 3 possible outcomes according to variable flag result in the if statement. So if flag is 2, it means the matrix has infinite solutions. If flag is 3, it means that the matrix has no solution, or other words, the matrix is inconsistent. Or else, if the flag is not 2 or 3, then the function prints the actual solution. The next method here is for checking consistency of the equation, and it takes the matrix A and flag as input and returns the updated flag based on whether infinite solutions or no solution exists. The last method is main method. It initializes the augmented matrix A with coefficients and constants of the system of linear equations. It calls for other methods, which I just described, and finally prints the augmented matrix and the solutions if they exist. So I have inserted the specific elements so that I have three equations and three unknowns. And here is the result. Thank you for your attention.